So the next couple of examples that we're going to take a look at are graphing, once again, solving by graphing, but we're going to be doing a manual graph. Okay, so we will not be using our graphing calculators. So the first example will be to solve a system of linear quadratic equations. We're going to go and graph y equals x squared plus 3 in brackets squared plus 2. This is your quadratic. And y equals negative x plus 1, which is your linear function. Okay, so let's start with our quadratic. It's in vertex form. So we can see that the vertex is at negative 3 and 2. Remember the number inside the bracket when we remove it from the bracket to put it into our so that we can discover what our vertex is, we choose opposite sign. Okay, and the number on the outside, we leave the sign the same. Okay, we can also see that A is positive, so it opens up. And we can also see that it is congruent, okay, meaning it has the same shape to y equals x squared, which is your basic function. Okay, so we'll graph that first. So vertex at negative 3 and positive 2 right here. And we know it's going to open up, and we know it's congruent to y equals x squared, so it'll have the same step pattern. Okay, so our first step will be 1 over and 1 up. Then starting from this point, our next step will be 1 over and 3 up. Okay, and we do the same thing on the left of the vertex, 1 over and 1 up, and then 1 over and 3 up. So here is our quadratic, our parabola. Okay, and that's y is equal to x plus 3 squared plus 2. Okay, so the next line that we will graph is our linear function. And you can see that it is in slope-intercept form. So our slope is negative 1, right? Because it's negative x, that's understood to be negative 1. So you can put over 1 so that you know that it goes down 1 and to the right 1. And our y-intercept is 1. Okay, so let's plot our y-intercept. Our slope is negative 1, so we want to go down 1 and to the right 1, and we do that a few times. And we can also go up 1 and to the right 1, and up 1 and to the right 1. And we can see that we will have points all the way along here. Okay, and remember, if you have a negative slope, your graph will go from the top left to the bottom right. Okay, so this is y equals negative x plus 1. Okay, so you can see that you have a point of intersection right here, which is at negative 2 and 3. And we have a point of intersection right here, which is at negative 5 and 6. Okay, so the next thing we want to do is to verify that those points are indeed the right points. Okay, so let's start with negative 5 and 6. We want to plug them into both our quadratic as well as our linear. So our quadratic y is 6, x is negative 5. So we get 6 is equal to negative 2 squared plus 2, and we get 6 equals 4 plus 2, so 6 is equal to 6, and so that works on that equation. Okay, but it also has to work for the second one. So y equals negative x plus 1. We are going to plug in 6 for y, and we want to plug negative 5 into negative x. So remember, we're going to put negative and then a bracket, negative 5 and plus 1. And minus a negative number means you're adding, so that makes it plus. And so we get 6 equals 6. And so we can see that the point negative 5, 6 is a solution for both graphs. Okay, so it satisfies both equations. Okay, our second point is negative 2 and 3. Let's plug that into our quadratic. And we get 3 is equal to negative 2 plus 3 squared. That gives us 1 squared, and so we get 3 is equal to 1 plus 2, which is 3. All right, and let's plug that into our linear function. Y is 3. Once again, we're going to plug in a negative number for x, so put minus bracket negative 2. Minus a negative means plus, and so we get 3 equals 3, so that works. Okay, so we've shown that both negative 5, 6 and negative 2, 3 are solutions. So the solutions are negative 5 and 6 and negative 2 and 3. Okay, and our next video will do the example number 2.